Look at that, we're recording. So last time I saw you, we did those first level solving rational equations. We did part 1. Today we are doing part 2, solving rational. I don't know why I'm writing this up there, saying it should be plenty. Rational equations, part 2. Right? And what we're doing is we're doing the level 3 problems, which means we're going to have a little bit more work to do. The last time we worked on this stuff, every single problem that you got had the same denominator. So can you imagine what we will be working on today? That's right, problems with different denominators, which we're going to have to find common denominators for. And as I said, I'm only doing 2 sample problems because all of your problems are in level 3. I pulled the sample problems off of Delta Math so that they would be similar to the problems that you're doing in Delta Math. First one we're going to do is we're going to solve for all values of x. That is what it'll say in Delta Math, so that is what I'm going to say here. Solve for all values of x. Why does it say values? Because you might have more than one x value that makes it true, just like the last time we were doing stuff like this. First problem is going to be 1 over x minus 7 minus 6 over x squared minus 7x equals minus 2x over x minus 7. So looking at this right now, you can see that clearly we do not have common denominators, right? We have 2 with common denominator. We have this one with the x minus 7, and we have this one with the x minus 7, but this one, not the same. When we want to find a common denominator, first we have to factor everything we can factor. And so the only thing factorable at this point is this one right here, right? X minus 7 can't be factored. X minus 7 can't be factored. But this one has an x in both pieces, so we can factor that down. And I'm just going to right here rewrite the 1 over x minus 7 minus 6. And I'm going to go ahead and write the factored version of this. I'm going to pull an x out of each piece. If I take an x from x squared, I'm left with an x. Minus, if I divide 7x by x, I'm just left with negative 7. And note that now we have a little bit that's similar in our denominators, right? Because every piece now has an x minus 7 component. So the only difference between this denominator and the other denominators is that x that's being multiplied to it. Does that make sense? Thank you, Suna. I appreciate that. I just need a yes once in a while to make sure I'm being heard, just like a human being, right? So the way I'm going to handle that is I can make these the same if I just multiply this times x over x, right? Because that'll make this bottom part x times x. And if I multiply this times x over x. Now I have to multiply the numerator and the denominator when I'm doing this because that's like multiplying by 1, right? If I multiply something by 3 over 3, it's still multiplying by 1. So we're not changing the value, which is why we have to do the numerator and the denominator when we multiply that out. So what's going to happen is x times 1 is just x over x times x minus 7. This one we don't have to do anything with, so we just have 6 over x times x minus 7 equals minus 2x times x is minus 2x squared over x times x minus 7. And so what happens now is we have the same denominator for everything, which means that now we can clear that denominator, right? We can get rid of the fraction altogether. And the way we would do that is we're just going to multiply all of this, each piece of it, by x times x minus 7. Why does it work? Because technically, if I wanted to, I could write this all as one equation now and cancel it out. But I'm just going to go ahead and do it without having to rewrite it. Once I multiply this times x times x minus 7, anything below it that is x times x minus 7 can cancel. So this, and this, all canceled, right? And all I'm left with now are the numerators. So now I have x minus 6 equals negative 2x squared. And now we can solve this. This is just a quadratic equation. So we could go ahead and solve this. I could add this 2x squared to both sides. And I wind up with 2x squared plus x minus 6 equals 0. Now, if you want to, you can go ahead and plug that into a calculator, right? An online calculator, and get your answer. I cannot do that in good conscience because I have a degree in math, and to plug in a quadratic and not solve it is sacrilegious when you have a math degree. So I'm going to go ahead and plug this into the quadratic formula. If you remember correctly, the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4 times a times c over 2a. And our a, b, and c are just the coefficients of this quadratic equation, right? So a would be the coefficient of x squared, which is 2. B would be the coefficient of x, which is just 1 because there's nothing written there. And c would be my constant term. It's got no variable, so that would just be minus 6. And we just plug these into the formula. X equals minus b. Well, that's minus 1. Plus or minus b squared. Well, that's just going to be 1 squared. Minus 4 times a, which is 2. C, which is negative 6. All over 2 times a, which is 2 times 2. I'm just going to write 2 times 2 as 4 instead of writing that out just to save myself a little time. And then I'm just going to do the math on this, right? Minus 1 plus or minus, well, 1 squared is 1. Negative 4 times 2 is negative 8. Negative 8 times 6 is plus 48. So 1 plus 48 is 49, which is convenient because that makes a perfect square over 4. So that would be negative 1 plus or minus 7 over 4. So let's look at what that is. What are my two x solutions? Well, one of them is going to be minus 1 plus 7, which is 6 over 4. And the other one is going to be minus 1 minus 7, which is minus 8 over 4. And we would reduce those fractions, right? And we would get, ooh, I don't know how I did that. I don't know why is that moving so much? Okay. And so x here would be 3 halves, and x here would be negative 8 divided by 4 is just negative 2. And that would be our two solutions, right? And if you don't remember how to do the quadratic formula, don't do it. Plug it into a calculator. I'm okay with that. What I want to know that you can do is this part, right? We've already been tested and tried on the quadratic formula. We don't need to be proving that anymore. Normally, if I had you in class and I had time, I would be doing all of it. I'd make you do all of it, but we're running out of time. So, which is why we're only doing two sample problems today. Calculator, the new favorite math app. I would rather use a calculator than like Photomath to solve it, you know? So, one more time, we are going to solve for all values of x. And this one's going to get a little crazier. But then we'll be done because I promised you there's only two. So what if I have 8x over x minus 3 minus 3 equals 1 over x? What do you think the common denominator is going to be on this problem? It's not LMAO. Oh, it's LOL. Now, I posed this question to my last class, and they seem to think it would be x minus 3. And I can understand why they might think that, because this one has x minus 3, this one has nothing, and this one has x. So it feels like all it's missing is that minus 3. But we're dealing with multiples of things, and so x minus 3, like I can't multiply anything to x to make it x minus 3. So ultimately, the common denominator would be x times x minus 3. Because this piece has an x minus 3, and this piece has an x. So I would multiply this. Well, let me do it over here. I'll multiply 8x over x minus 3 times the part that it's missing, which is x over x, right? Then I'd go minus 3. I am going to multiply that times the whole thing, right? I'm going to multiply this times x times x minus 3 over x times x minus 3. And then this part, this 1 over x, I'm just going to multiply times the part it's missing, which is x minus 3 over x minus 3. Now, what does that do? Makes a mess, especially right in here. But let's look at this problem, right? Here I have 8x times x. Well, that just gives me 8x squared. And we'll just keep that as x times x minus 3, right? We don't need to multiply that out. This I'm going to have to distribute a little bit. X times x is x squared. X times negative 3 is negative 3x. And this is going to be minus 3 times x squared. Well, that's minus 3x squared. I guess I already did that with the minus, right? So we have minus 3x squared. This, let me get rid of that minus right now. I keep doing that. I keep wanting to write the minus even though I have the minus written right there. So that's minus 3x squared. Then I'm going to go 3 times negative 3x is going to be plus minus 3x times, that would be plus 9x all over x times x minus 3. We're just keeping that denominator the same. 1 times x minus 3 is just x minus 3 all over x times x minus 3. And there's a reason I'm not multiplying out these denominators. And the whole idea between not multiplying out the denominators is that we're going to clear them anyways. They're all the same. That's all we care about. We don't care what form they're in. We just need to know that they're all the same. Because once we're all the same, all I have to do is multiply this whole equation, right, by whatever the denominator is. So in this case, it's going to be times x minus 3. And what that does is it clears the denominator on all of the pieces. And so all I'm going to be left with on this are 8x squared minus 3x squared plus 9x equals x minus 3. And now I can solve for x, right? Is this extensive and time consuming? Heck yeah, it is. That's why I'm only doing 2 of these problems. First thing I'm going to do, I'm going to move everything over to one side. Before I do that though, 8x squared minus 3x squared, I can put those together and have 5x squared plus 9x equals x minus 3. So I did a little combining there. Next thing I'm going to do is I'm going to move over the x. I'm going to subtract x from both sides. And then I will have, sorry, I'm just trying to move the screen up a little bit. Then I'm going to have 5x squared. 9x minus x is plus 8x equals negative 3. Then I am going to move this 3 over. I have minus 3, so I'm going to add 3 to both sides. And then I would have 5x squared plus 8x plus 3 equals 0. And again, I'm going to plug that into the quadratic formula. And if you don't remember how, you're going to use a calculator. But I'm just going to go ahead and figure out that my A equals 5 and my B equals 8 and my C equals 3. And I'm going to go x equals minus B. Well, that's minus 8 plus or minus 8 squared minus 4 times A, which is 5, and C, which is 3, all over 2 times A. 2 times 5 is 10. And now I'm going to just do the math and find those answers. Minus 8 plus or minus 64. 8 squared is 64. 20 times 3 is 60, so that's minus 60, which is going to make this a little simpler for us. And now we're just going to reduce this. Why I say that's going to make it simpler is that 64 minus 60 is just 4. So we have minus 8 plus or minus the square root of 4 now over 10. And the square root of 4 is just 2. So I have minus 8 plus or minus 2 over 10. Our two solutions are going to be a mess. They're a mess because I cannot make that stop moving. I'm going to have x equals, well, I'm going to have minus 8 minus 2. Minus 8 minus 2 is negative 10. Negative 10 over 10. And then I'm going to have minus 8 plus 2. Well, that's negative 6 over 10. And then we're going to reduce those fractions. Negative 10 over 10 is just negative 1. Negative 6 over 10 is negative 3/5. And that is going to be our solutions. But you guys are welcome to use a calculator to find those out. Those are the only problems I'm doing in this set. And the reason for that is it's just an extension of the last time. It's just part 2. It's just to show you how to do it when the denominators are different and you have to find that common denominator. So once we get that common denominator and we clear out those denominators like we did before, everything solves the same, right? You might have to factor, you might have to quadratic equation, but all it becomes is just this equation that you guys have been solving all year long at this point. So I'm going to stop the video.